This will be an attempt at describing parallel DC and AC systems in a tiny house, or RV for that matter. Same deal. In this system, we have DC components on the left, AC components on the right, and the interface between the two is in the center. On our AC branch, shore power is coming in from the bottom, so this will be 30 amp service into a 100 amp sub panel. All of the breakers in this section are outlets, and these two breakers manage the input. They are separated by a isolation device, so only one of these breakers can be turned on at a time, and each of these breakers are 230 volt, so that's both legs of your AC system. These are all one leg each. The DC system power comes in on these lines here from the solar panels into the panels or into their own breaker in the DC breaker box. The power then is sent up to this charge controller. This is not a particularly good one. I would recommend getting a better one. And then the charge controller sends voltage to the batteries on these two lines here. So these two lines go through the breaker and then down. The batteries are stored under this panel in the floor. The charge controller only manages battery voltage in this system. No, that's not true. It also manages the output voltage in this system. So it's monitoring input and output power, and the output power goes to this block. So there's DC fuses under this block that power various pumps and lights in the house. There is two high current lines also connected to the batteries here that come up through this high current DC fuse into our inverter. And the inverter is capable of matching the DC system with the AC system. So it's currently running on shore power because this breaker is turned on. This breaker is connected to this device. So if we were to turn on this inverter, wait for it to boot up, and then push up on this breaker, you'll see that the rocker switch turns off the shore power. And now the AC system in the house is running on the inverter. We have too much power currently turned on for the inverter, so it's going to very quickly overheat. So I'm going to put this back, and you'll see the isolation device again manages to turn off the inverter breaker when I turn on the shore power.